solution to solve this problem. Okay? Yeah. Yeah. All right. To do that, we need to do some, we need to use some important results. Yeah. All right. So here, we cannot use the same results of question number 24 in this assignment. Yeah. If you use that same way, you cannot get a comparison solution. Yeah. All right. So to do better, yeah. So the general idea elimination method. Okay. Yeah. But how to apply the elimination method? Then you need a lot of experience. You need a lot of analysis work. Yeah. It's not easy. Yeah. Here I want to give you one closely related example. Yeah. All right. So here the elimination method. Yeah. Actually, we have many examples. Yeah. So far in this class, we did many examples based on the elimination method. Yeah. So you should have plenty of experience. All right, so here I give you another important example. All right, so our goal here to find an 8 comparison result solution. Yeah. All right. So definitely we need to use our resource. So these A comparison, so we treat it as our resource. So we don't want to waste our resource. So we want to use our resource in an efficient way. Okay? Yeah. All right. So now the third largest. Okay? Yeah. The first question. So now I like to do some analysis. Do some analysis here. Okay? Yeah. The first question. In order to find the third largest element, do we need to find the largest first, then the second largest, and after that the third largest. Yeah. The reason I ask this important question, because in order to save just one comparison, you really need to arrange these 6 elements in a well-organized way so that you do not want to waste any comparison. So you want to use your comparison in an extremely efficient way. So the question, so let me tell you the answer of this question. The answer is no. No. Okay? Yeah. Based on your intuition, you may feel yes, right? Based on your intuition. Yeah. Yeah, but actually, so here, let me give you the main point here. So why the answer is no. Yeah. So let me explain a special situation. Yeah. If you can determine that one element is in top 2, then you can eliminate it from the consideration because it cannot be the third one, right? I'm on top 2. Okay? Yeah. So that's simple. If you can determine one element among the top 2 cannot be the third largest, so you can eliminate it safely. Yeah. But you just determine in top 2, but you do not know if it is the largest or second largest. We do not know that. That's possible, just among the top 2. Is there such a situation? Yes, there is a concrete example. Okay? Yeah. So here I want to show you, give you a concrete example. And in this example, the idea, the way we use the elimination pretty close to the method you need to use to solve this problem. Yeah. So the next slide, I will show you this example and solution. Okay. So the example, I gave this question a few times, but I didn't find a chance. I couldn't find a chance to give you the solution. Yeah, so here I have a chance to give you the solution. So that example. The example is find the median of a 5-element array. This question, okay? I never gave you the solution. So this time, right here, I will give you the solution. Okay? Yeah. All right. We know the answer, right? 6 comparisons. But how to use 6 comparisons? Yeah. So let me give you the solution. All right. Step 1, or round 1 comparison. Round 1, we apply the tournament method. Yeah. So we arrange our data in this way. Tournament. So you know the tournament. Compare x1, x2, and we can assume x1 is the winner. Okay, that's our first comparison. Then x3, x4. This is our second comparison, and we can assume x1 is the winner. Then the third comparison, and we assume x1 is the winner. So in this round, we have 3 comparisons, and x5 we do not touch it. All right, so that is round 1. 3 comparisons already used. The second round, we need to use the remaining 3 comparisons to find the median. So it's not very hard, not too complicated. In our round 2, now let's draw a diagram to view the data relation. All right. So x1 at the top, then x3, x4, x2 below x1, and x5 is here. Let us do some analysis. Okay, do some analysis here. Okay. Now, elimination method. So here, I want to put the title, elimination method. Okay? Yeah. All right. Now, when you look at x1, it is greater than all the elements except x5. Okay? Yeah. Greater than all the elements except 5. The only element that x1 cannot be greater than is x5. That means only x5 has a chance to be greater than x1. So what's the meaning of that? Okay? The meaning of that is x1 is among the top 2. Right? X1 is among the top 2. So remember in the previous slide, I wrote, you can determine one element that is among top 2, but you do not know if it is the largest or second largest. Here you see this concrete example, x1 is among the top 2, but you do not know if x1 is the largest or second largest. Okay, so you see it. That could happen. Okay, so then, based on this property, we can say x1 cannot be the median. Okay, all right. So we can eliminate it. Eliminate it from the consideration. Right? Yeah. Okay. All right. After we eliminate it, now, so what do we have? X2 here, X5 here, but we don't know which one larger, which one smaller. X3 here, X4 here, right? Yeah, so that's what we have. Yeah. All right. Now, comparison number 4, we compare X2 and X5. This is the comparison number 4. And we can assume X2 greater than X5 without loss of generality, right? Yeah. Because, you know, symmetric. Yeah. You put X5 on top, X2 on top, you know, these two cases, basically symmetric. So you only need to take one of the two to study. It's enough, okay? Yeah, so that's number 4, all right. Then, let's do a summary a little bit, because our goal is the median. Yeah. So the original median is just the second largest in these 4 elements: X2, X3, X4, X5. Okay? Yeah. The second largest. We just find the second largest. Okay? All right. Now, so let's do comparison number 5. Okay? Yeah. Compare X2 and X3. The larger one will be the largest of these 4 elements. Okay? Yeah. So here we can assume X3 is larger without loss of generality because they are symmetric. The situation, you know, completely symmetric. Yeah. All right. So X3 is largest. Then what is the second largest? How to find the second largest? Okay? Yeah. Here you can see X4 cannot be the second. X5 cannot be the second largest. Yeah. Why? Because it is lower than X2. So only X2 has chance to be the second largest. And X5 is smaller than X2. So X5 has no chance to be the second largest. Because other than the largest, there is one element above X5. So X5 cannot be the second largest. That means we can eliminate X5 here, right? Yeah. After elimination, only 2 elements left. X2 and X4. You just need one comparison to get a larger one. This one could be X2, could be X4, and this is the second largest. Right? And it is the original median and the solution. right? Yeah. And then this comparison is number 6. Yeah. This, yeah, number 6. Yeah. A little larger. Okay. So you can see this example, yeah, very useful to help you find the solution. But even with this example as the background, so you need to do some critical, smart, important work to complete the solution. So that's why it is worth 2 more bonus points. Okay, you can try. So if you run out of time, so then, even after this semester, yeah, but I will give you the solution. So yeah, I will. So yeah, you can try your best. Yeah. Before the final, I will post the solution. Okay. Yeah. All right. So that's it. So that's all the hint videos I can give you. Okay. All right.